Hello Algebra 1 students, this is Mr. Wilson, and in this video we are going to learn how to simplify rational expressions. Now you've seen this word rational before. For example, a rational number is some number that can be written as a fraction of two integers, like 2 over 7. That's a rational number. Now, a rational expression is going to look something like this. Let's say, 3x squared minus 5x plus 10 divided by, 6x minus 12. Okay? This is an example of a rational expression. And all rational expressions have some polynomial divided by another polynomial. And of course you know that a polynomial is just some expression that looks like this, right? It's got numbers in it multiplied by powers of x or some other variable, some other letter, all right? So let's give a concrete example of how to simplify a rational expression. Okay, in this problem, our rational expression is x minus 1 divided by 5x minus 5. Now, let me give you a thought bubble out here with something that you're a little bit more familiar with. If I ask you to simplify some other sort of fraction, like, let's say, 21 divided by 6, the process that you would go through to simplify 21 over 6 is to factor the top and the bottom, like this. 21 is equal to, say, 3 times 7, right? How about 6? 6 is equal to 2 times 3, okay? And this is as factored as you can get because all of these numbers are prime. You can't factor them into any smaller pieces. Now from this point, you know that you can cancel out the 3 on the top and the 3 on the bottom. But of course you can only do this because the operation on the top and the operation on the bottom is multiplication. So once the 3's are canceled out, what is left over is 7 divided by 2. And this is the simplified form of the fraction 21 over 6. Now that is exactly what we're going to need to do when we are simplifying rational expressions. We need to factor the top of the fraction and the bottom of the fraction as much as we can and find things that we can cancel out. That is basically the name of the game when it comes to simplifying rational expressions. So let's look at this problem. Is there anything that we can factor out of the top from both terms, from both the x and the negative 1? Well, no, not really. So let's keep x minus 1 the same on the top. But how about the bottom of the fraction? Is there anything that we can factor out of 5x and negative 5? Well, yeah, we can factor out a 5 from both of those terms. Now, what is left over after we factor out a 5? Well, x minus 1. Do you see that? Now remember that factoring is just the opposite of the distributive property. You should know how to do the distributive property in your sleep. Factoring, in this case, is just the opposite of distributing. Now once we factor out this 5 here, look at what is left over. X minus 1 on the bottom of the fraction and x minus 1 on the top of the fraction. This means that we can cancel the whole x minus 1 out from the top and the bottom. Now let's think about what is left over after we cancel out x minus 1 from the top and bottom. Well, there doesn't appear to be anything left over on the top of the fraction. That really means that there's a 1 left over, and we are dividing by, well, there's a 5 left over. So this was a pretty straightforward problem. The simplified form of this expression here is 1 over 5. But we're not quite done yet. Look at what the rest of the problem asks us to do. State any excluded values. Now, an excluded value, this means what numbers will make the bottom of the fraction, or the denominator, equal to 0. Now remember that you can't divide by 0. If you try to divide by 0, let's say 7 divided by 0, undef. That means undefined. So you can't divide by 0, even when you are dealing with x's, like we are in this expression here. So an excluded value is a number that we can stick in for x that will make the denominator equal to 0. Now, it doesn't matter what happens on the top of the fraction. The only thing that matters is what happens on the bottom of the fraction. So can you see what number we can stick in for x that will make the bottom of the fraction equal to 0? I hope that you said 1. 1 is an excluded value, because if we stick it in right here, or even easier to see, if we stick it in right here, then the denominator of the fraction becomes 0. So the way that we write that is, okay? So these two pieces go together. So let's look at another example of simplifying rational expressions. Let's look at problem A here. 21 times a squared divided by 7 times a cubed. Now this is pretty easy. Remember, the goal is to cancel out as much as you can from the top and the bottom of the fraction. Well, here's one way to do it. 21, I know, is 3 times 7, and a squared is just a times a, and we're dividing that by 7, which is prime, so we can't split it up, times a times a times a. Well, look here. The 7's cancel out, these two a's cancel out, these two a's cancel out, and look at what we're left with. 3 divided by a. So it appears that that is the simplified form. But what is an excluded value? What number can we stick in for the variable that will make the denominator equal to 0? Well, if a is 0, then the denominator of the fraction is equal to 0. So that is our excluded value. All right, let's try B now. 18 times d squared divided by 4 times d plus 8. Well, the name of the game here is factor. Factor, factor, factor. So let's try to factor 18 as much as we can. I know that 18 is 2 times 9, and 9 we can break up into 3 times 3, right? Yeah? And then d squared is d times d, right? Then we're dividing this by, well, 4d plus 8. Is there anything that I can factor out of 4d and the 8? In other words, is there anything that I can take out using the reverse distributive property? Well, I can factor out a 4, can't I? 4 times d plus 2, right? And then, of course, 4 is just the same thing as 2 times 2. Now, this appears to be as factored as we possibly can get it. Now, let's see what we can cancel out. Well, it looks like there's only one thing that we can cancel out. The 2 here and a 2 here. But here's the question for you. Why can't the 2 on the top cancel out with this 2? Or here's another question for you. Why can't this d cancel out with that d? The reason is that you can only cancel out things that are multiplied. You can't cancel out things that are added. The only way that we could cancel out anything from inside here is if we had a factor of d plus 2 at the top, which is multiplied by all the other stuff. But we don't have that. So we cannot touch anything inside the set of parentheses. But we can touch this 2 and that 2, and they cancel out. Now, when I cancel out that 2, look at what is left over on the top of the fraction. Well, this is just 9 times d squared. And look at what's on the bottom of the fraction. 2 times d plus 2. And it is okay to leave the bottom factored like this. Now, what is an excluded value of this expression? In other words, what value for d makes this equation true? Well, if d is equal to negative 2, then clearly that would make the equation equal to 0. So that means that an excluded value of this rational expression is that d cannot equal negative 2, because if it did, it would cause the denominator of the fraction to be 0, which we cannot have. Okay, let's look at c now. 2n minus 3 divided by 6n minus 9. Let's see. It doesn't appear that we can factor out anything from the top, but how about the bottom? Looks like we can factor out a 3, can't we? 3 times what? 3 times what will give us back what we started with? Let's see here. 2n minus 3, right? So we have 2n minus 3 on the top and 2n minus 3 on the bottom. That means cancel those guys out. What's left over? 1 over 3. Piece of cake, right? Now, what is an excluded value? In other words, what number will make this equation true? Well, let's see here. 6n would have to be equal to 9, which means n equals 9 divided by 6, which is 3 divided by 2, right? So it looks like an excluded value is that n cannot be 3 over 2, because that would make the denominator equal to 0. All right, let's take a look at this example. 3x minus 6 divided by x squared plus x minus 6. This is our rational expression, and we want to simplify it. Now, the steps are going to be exactly the same as in the previous problems. The first step is to factor. Factor the top of the fraction and the bottom as much as we possibly can. All right, what can we factor from 3x and from negative 6? What is the GCF of the top of the fraction there? Well, it looks like we can factor out a 3, can't we? 3 times, it looks like x minus 2, right? So this is the factored form of the top of the fraction. Now let's look at the bottom of the fraction. Now the bottom of the fraction here looks a little bit different from what we've already seen in this video. We cannot factor it by factoring out a GCF because there is no GCF of the 3 terms in the bottom of the fraction. But we can factor it in a different way. Remember that we can factor quadratic trinomials, in other words, things that look like this. We can factor these into a set of parentheses where each parenthesis has 2 terms in it. Now in this case, we can use the shortcut to factor this because there's an invisible 1 multiplying the x squared term. That means our factored form is going to look like this, x and x. And all we need to do is find the magic numbers that we put here and here. Remember, the way to find the magic pair of numbers is to think, what 2 numbers multiply to equal the last number, negative 6, and those same 2 numbers add to equal the middle number, which is the number multiplying the x, which in this case is an invisible 1. I hope you said that negative 2 times positive 3 equals negative 6, and negative 2 plus 3 is equal to 1. So it looks like those are a magic pair of numbers. X minus 2 times x plus 3. Now once we have that, our rational expression has been completely factored. Now let's try to cancel out. Remember, step 2 is to cancel as much as we can from the top and the bottom of the fraction. Well, it's pretty clear to see that there's an x minus 2 in parentheses on the top and an x minus 2 in parentheses on the bottom. So we can cancel out x minus 2, and we are left over with 3 divided by x plus 3. Now you might be tempted here to try to cancel out the 3 on the top and the 3 on the bottom. But you cannot do that. You cannot cancel out these 3's. Why not? Well, because the operation on the bottom is addition. We cannot cancel out things that are added together on the bottom of the fraction here. We can only cancel things out if the operation between them is multiplication. All right, now the last step here is to find any excluded values. In other words, what numbers can we stick into the bottom of the fraction to make it equal to 0? Well, I hope it's clear to see that x cannot be equal to negative 3. Because if it was, negative 3, if you stick it in right here, will make the bottom equal to 0. So negative 3 is clearly an excluded value. But there's another excluded value. The other excluded value is positive 2. Because if you stick in a positive 2 right here, that would also make the bottom of the fraction equal to 0.